Good morning, everyone. This is going to be my workshop video number 2. This is Travis Justice, and this is my Batman Arkham City project, previously DFA project, now updated to include a memory stack to solve new problems, which I will get into shortly. So this is a bit of a review from my DFA project previously. States in the DFA represent different patrol patterns that enemies will follow depending on their level of fear, either inflicted by Batman or other factors. And the input alphabet includes all major events that I could think of to happen in one of the Predator encounters in Batman Arkham City. And the important note, once again, is that this is still from the perspective of one enemy, meaning that if all of the enemies are defeated, in quotes, but this enemy still remains conscious, then that will be an invalid string, as we will get into shortly. So once again, our alphabet includes if there is no sign of Batman, someone finds a gadget, someone sees Batman, or the rest are Batman taking down enemies in various methods, and then finally if Batman gets taken down by the enemies. This slide I didn't fully update, but I did have a incorrect definition of the language previously, but I was able to fix that in my in-class presentation. But L still is the set of all strings in X such that X is a combination of takedowns or maneuvers, which includes the death of Batman or the takedown of all enemies. And again, an important note here is that any input can be used at any state, so there are no illegal sequences that will result in an invalid input. Any input can be used at any state to go to another state or the same state. Now, the new capabilities that I was able to achieve with the memory stack. Previously, I could not really keep a count of remaining enemies. I just basically went to the end, and if Batman wasn't dead, then Batman wins. If Batman was dead, then the enemies win. Now I get to be a little bit more complex with it. Now it pushes an X onto the stack for each enemy that enters the fight. And then if the stack is empty and the state is in Q5, which means Batman has defeated the enemy that is the perspective of the automata, then that is a valid win condition for Batman. And then regardless of how many enemies are remaining, if the state is in Batman's death state, then that is a valid win condition for the enemies. So this was my DFA diagram, and I thought this was complicated. But then I went forward and made my PDA, and we've got a little more going on here. So essentially you can see that if something like A is red, then it pushes an enemy onto the stack. This is the best way I could think of to do it. If no enemy is taken down, it pushes an X onto the stack. And if something like input of D happens, that means that there's a silent takedown, then there is an X pushed off or popped off of the stack to simulate Batman taking down that enemy. Now for the code side of things, implementing in C++, this was pretty simple. I was able to start with the base code from the DFA stage, so that was good, and it helped me save a lot of time. I added an int that is enemies remaining in order to keep track of how many X's are on the stack, in a sense. And this works in the same manner as a memory stack. Every time one of these states happens, I was incrementing. I was essentially incrementing the integer every time an X was pushed onto the stack, and I was decrementing whenever an X was popped off of the stack, aka when Batman takes down an enemy. So if I can show you the code side now, and I didn't have that open. One moment. All right, now we're back. So this is the code side of my my PDA. It looks very similar to the DFA code, but there is a couple differences. Now I have a more accurate prompt here. First of all, I had previously this said enter alphabet for input because I had a little misunderstanding there, but I was able to get that sorted out. And then I have at the beginning of each iteration of the loop, as it loops through the input, it gives a current count of the enemies remaining. And enemies remaining starts at 0. So if this is one limitation I found that I wasn't totally able to get around. I could have started the int at like a number of like 3 or something, but the only problem with that is that you don't start with an X on the stack, if that makes sense. So I couldn't find a way to do that anyway. That might just be a limitation of my knowledge, but that was one limitation I will make note of, is I wasn't really able to fully simulate accurately the actual what happens in the game. However, I think I got a pretty good representation, and I was happy with what I came up with. So essentially, if case A, B, or C occurs, an enemy is not being taken down, so it'll increment enemies remaining, no matter what state you're in, besides state 5, obviously, because that means Batman has already been knocked out, and that'll be the end of combat. The important thing here is that if an enemy was taken down, that I had to decrement. So I had to make sure I entered these carefully. And once again, if Batman is already taken down, then I did not increment or decrement. It just stayed the same. So finally, even for case F, this is a takedown in the line of sight of thugs, but it's still a takedown. So I still decremented the count. So then case G, this is another limitation that I found when implementing it, was that I could have done this with a Boolean value. But again, there wasn't a way to represent that in the PDA. I wanted to make sure that the enemy that I wanted to make sure case G had happened. I wanted to make sure that this thug had been taken down by Batman before it gave a defeat state. And there may be a way to do that. I admittedly did not. It might not have put enough time into thought about it, but I couldn't come up with a solution for that. So hopefully in the Turing machine stage, I can fix that. All right, so finally, if the state is 4 and enemies remaining is less than or equal to 0, I go to the defeat state and string accepted. If Batman is taken down, aka state 5, I put out victory state, enemies remaining, string accepted. And then once again, if it's not 4 or 5, then we're in an invalid string because that is not an accept state if it's not in 4 or 5. So that goes to not accepted. So I have a test input for the PDA for the victory state and the defeat state. So I will test those now. All right, so this is going to be my defeat state where Batman takes down all enemies. So you can see enemies remaining 0, 1, 2. Batman is stealthily taking down an ally, so it goes to 1. Then this state or this step in the PDA input, Batman did not take down an enemy, so then it'll increment to 2. He takes down another enemy, so it's 1. No sign of the bat, so it goes back to 2, 1, and then this enemy is taken down. So defeat state, string accepted, because there are 0 enemies remaining. And then finally, I will do a victory state. This is a victory state. You can see the same process go through here. Then Batman gets taken down, victory state, 3 enemies remaining, string accepted. So overall, I think this was pretty fun to implement. I had a good time with it. It wasn't as difficult as I had previously envisioned, so that was nice. I will, real quick, I don't know if this is even necessary, but I did want to show you a test input on the actual PDA itself to show you that it works. Okay, so if I step by state, I use the same test input as before. What? Okay, there we go. And then another important note here, I added it as accept by final state to make sure that it's in one of these states, because the stack does not necessarily need to be empty for it to accept. So you can see if I step here, it's adding X's to the stack. Now it's removing X's from the stack. And now enemy is victory. I should have, this is an error here. There should be 3 X's here. The reason that there's 4 is that I had to add an enemy when Batman dies, and I did not do that in the code side. So that is an oversight on my part. But I'll just test just for clarity's sake. I will test one more time with the victory state. All right, so step adds an enemy, takes an enemy off, adds an enemy. And then finally, G will pop off the last X remaining. It sees that the stack is empty and that we're in the defeat state. So that is an acceptable state. All right, I think that is going to do it for this workshop video. Thank you all for your time, and I will see you in the next one.